In this video, we are going to treat Equilibria and the application of Le Chatelier's principle. Le Chatelier was a chemist. After a series of research, he realized that his theory could be applicable in the industrial sector. Today, it is more applicable in the production of gaseous substances in the industry. So now we are going to treat this area, how we can use Le Chatelier's principle to explain the procedure or how an equilibrium could be achieved in a chemical reaction. Now, what is the theory or what is the principle of Le Chatelier? Le Chatelier principle states that if a system in equilibrium is subjected to a change, the system must react in such a way to oppose the change that have been imposed in it, thereby establishing a new equilibrium. What am I saying? What does that really mean? If a system is in equilibrium, according to Le Chatelier, any change imposed to a system in equilibrium, according to Le Chatelier, it must oppose it. For instance, if there's an increase in a particular condition that is in equilibrium, according to Le Chatelier, the system must react to do what? To decrease it. If there's a decrease in a particular condition, that is, if there's a decrease in a particular condition of a system in equilibrium, by Le Chatelier, the system must react to do what? To increase it. So precisely we are saying that if a system is in equilibrium, if a system in equilibrium is subject to a change, the system must react in such a way to oppose the change, thereby establishing a new equilibrium. By solving many other examples, you'll be able to understand what this means. For instance, let's take, for example, temperature. You know, we have discussed a lot regarding temperature. Apply Le Chatelier principle to deduce qualitatively the effect of changes in 1. Temperature on the value of Kc. From what we discussed last time, you saw that let's take for an ammonia. Ammonia, this is an exothermic reaction. Kc for ammonia is what? Kc here is Kc is equals to the concentration of the product is what? This is ammonia raised to the power of its coefficient, which is 2, divided by what? The product of the concentration of the reactants raised to the power of their coefficient. It will be nitrogen raised to the power 1 times hydrogen raised to the power 3. Yeah, this is the Kc for ammonia. Now we are told this is an exothermic reaction. This is an exothermic reaction. We are told Apply Le Chatelier's principle to deduce qualitatively the effect of changes in temperature on the value of Kc. Now, this is an isothermic reaction. Increasing the temperature here, the production of ammonia is more favorable under exothermic condition. So if we increase now changes in temperature, if we increase the temperature of ammonia of the system, if we increase the temperature of the system, what happens? More of the equilibrium shift but to what? To the left. This is an isothermic reaction. And it's an isothermic reaction favoring the production of ammonia at this low temperature. But if the temperature is increased, what happens is going to favor but the endothermic reaction. Is more of the ammonia is going to be decomposed. It's going to be decomposed into nitrogen and hydrogen. And when more of the ammonia gets back to nitrogen and hydrogen, what happens? Our Kc is going to drop. Why do I say our Kc is going to drop? There's less ammonia and there is more of the reactant. And Kc is equal to what? The concentration of the product raised to the power of the coefficient divided by the product of the concentration of the reactant raised to the power of their coefficient. In this case, there is more of the reactant than the product. Therefore, the Kc is going to what? Is going to drop. Secondly, if we decrease the temperature, the temperature, how will a decrease in temperature affect the value of Kc? Once more, this is an isothermic reaction favoring the production of ammonia. Decreasing the temperature is going to favor the production of more ammonia. Decreasing the temperature, equilibrium will shift more but to the right. More of the product is formed. And our Kc will do what? The value of the Kc is going to do what? It's going to increase. Because there is more of the product than the reactant. Okay. Let's go to concentration. Let's use a concentration. Increasing the concentration at constant temperature. What will be the effect of increasing the concentration at constant temperature? Okay, now, the effect on Kc. The concentration, for instance, if we increase the concentration of hydrogen here, if we increase the concentration of hydrogen here, the equilibrium has been distorted. According to Le Chatelier'S, if we increase the concentration here, the equilibrium has been distorted. There is more of the reactant than the product. If we increase the concentration here, what happens? According to Le Chatelier, you have to oppose it. So the equilibrium will shift to what? The equilibrium will shift to the right. Equilibrium will shift to the right to do what? To decrease the hydrogen for the formation of more ammonia, thereby establishing a new equilibrium. Once more, if we increase the concentration of nitrogen or hydrogen, if we increase their concentration, the equilibrium is no longer there. The equilibrium has been distorted. For that reason, by Le Chatelier, the equilibrium will have to do what? Will have to shift to the right, leading to the production of more ammonia, thereby decreasing the hydrogen or the nitrogen, thus establishing an equilibrium. Now, let's take another example. Pressure. This is pressure. Gas pressure has to do with substances, gaseous reactions. We are still going to use ammonia, the production of ammonia in this reaction. Gas pressure has to do with volume. Gas pressure has to do with more frequent collision and successful collision. Gas pressure has to do with the volume and more successful collision and the number of gaseous particles. Volume, number of gaseous particles, and the rate of collision. In this example here, ammonium, nitrogen plus hydrogen to give ammonium. Since it has to do with the number of gaseous particles, here we have 4 moles of the reactants, 3 moles of hydrogen and 1 mole of nitrogen, making a total of 4 moles of the reactant, producing just 2 moles of the product. So 4:2, or 1:2. 4:2. Now, if the pressure is increased, if the pressure of the system is increased, what happens? If the pressure of the system is increased, when there's high pressure, there is more frequent successful collision between the particles and the walls of the container. When there is more pressure exerted on the walls of the container, what happens? By Le Chatelier's principle, gaseous particles will have, in order to reduce the pressure, will have to move to the direction of less pressure. In that case, they will have to move to the direction of less gaseous molecule. Let me just illustrate this to you to understand better. I have a system here. This is a system. This is a balloon. We have a smaller volume and we have a larger volume connected by a pipe. And these two, the one with a small volume has more, the small volume has more gaseous molecules in it, with more frequent collision between the particles and the walls of this vessel. And when there is more frequent collision between the particles and the walls of the container or the vessel, there is more pressure exerted on the walls of the vessel. So there is high pressure here as a result of more frequent collision between the particles and on the walls of the container. On this other side, this is a larger volume with less number of molecules, gaseous molecules, with less frequent collision, with less gaseous molecule, with less frequent collision between the particles and the walls of the container, thus exerting less pressure. Between these two sides, there is high pressure here and there's less pressure here. When there is high pressure here, as a result of more frequent collision between the particles and the walls of the container, what happens? The particles here will tend to move to the direction of particles with less gaseous molecule. In order to do what? In order to reduce the pressure here and increase the pressure here. we are indirectly saying that here, when there's high pressure here with more molecules, gaseous molecules, the gaseous molecules will tend to move to the direction of less gaseous molecule, thus reducing the pressure here and establishing an equilibrium. Like in the case of ammonia, when there is high pressure, when there's high pressure, more of the nitrogen and the hydrogen will tend to do what? Will tend to move to the direction of the production of more ammonia, thus decreasing the pressure on the reactant side. In that case, the equilibrium will shift from the reactant to the product, favoring the production of more ammonia. This is just an illustration. Let's go back again. As I said, an increase in pressure at constant temperature on the value of Kc. When the pressure here is increased, in principle, the equilibrium will shift to the direction of less number of gaseous molecules. So the equilibrium will shift from left to right. And if the equilibrium shifts from left to right, more of the product is formed. And when there is more of the product that is formed, Kc will do what? Kc will increase because there is more product than more reactant. Kc in this case will increase when pressure is increased. Therefore, gas pressure will favor the production of more ammonia. And secondly, if the pressure is decreased. In this system here, if the pressure is decreased, in the system here, look at it. There's more pressure here with more number of molecules. There's more pressure here with more number of gaseous molecules than on the right. So if the pressure does what? If the pressure is decreased, what happens? In order to increase the pressure, the equilibrium will shift to the direction of more gaseous molecules. There are 4 moles here, and there are 2 moles here. In this system, if the pressure is decreased, for it to be increased, according to the Chatelier'S principle, the equilibrium will shift from what? From right to left. Equilibrium will shift from the region of less number of gaseous molecules to the region of more gaseous molecules. And when the equilibrium shift from right to left, it does what? There is more of the reactant than the product. And in that case, the Kc will do what? The Kc will decrease. The Kc will decrease because there is more of the reactant than the product. Once more, decreasing the pressure, the equilibrium shift but to what? To the area of more gaseous molecule, which is equilibrium shift from right to left. More of the reactant than the product. And when there's more of the reactant than the product, the Kc will do what? The Kc will drop, because Kc is equal to the concentration of the product raised to the power of their coefficient divided by the product of the concentration of the reactant also raised to the power of their coefficient. Let's go to catalysts. What happens to the catalyst? A catalyst is just a substance that will help to speed up the rate of a reaction. The catalyst will have no influence on the value of Kc. The value of Kc, the role of the catalyst is just there to speed up the reaction, to speed up, to make the equilibrium to be achieved in a shorter period of time. It helps to lower the activation energy. It helps the reaction to go faster. It helps an equilibrium to be achieved within a short period of time. So it has no value on the Kc. We are going to answer a few questions regarding this. Of course, regarding this section. By answering those questions, it will help us to better understand it. Let's go to the first example. The first example here is question number 1. Sulfur dioxide plus oxygen in an equilibrium gives sulfur trioxide. Of course, this is the process used in the contact. This is a reaction in the contact process, the production of sulfuric acid. Sulfur dioxide plus oxygen at equilibrium gives sulfur trioxide. Reaches dynamic equilibrium in a closed vessel. The forward reaction is exothermic. The reaction is catalyzed by vanadium 5 oxide, that is vanadium pentoxide. A. Explain the term dynamic equilibrium. In a dynamic equilibrium, this is a situation where the rate of the forward reaction is equal to the rate of the backward reaction. This is a situation where the rate of the forward reaction is equal to the rate of the backward reaction. Or you can say it is a situation where the reactants are being converted to product at the same time or at the same rate as products are converted to reactants. Once more, in a dynamic equilibrium, for you to achieve a dynamic equilibrium, it must be in a closed system, as mentioned in the question. Being in a closed system, it means that no substance is added, or no substance is removed. No substance is added or lost from the system. The system is closed. There's no addition or there's no removal. And in a closed system, the rate of forward reaction is equal to the rate of backward reaction. That is, the forward reaction and the backward reaction are occurring at the same time, where there is a dynamic equilibrium. And again, in the dynamic equilibrium, you should know that the concentration of the products and the reactants are constant. So nothing is added and nothing is removed. The concentration of the product and the reactants are constant. Be part of it. What will happen to the position of the equilibrium when 1. Some sulfur trioxide is removed from the vessel? Of course, this is an exothermic reaction. What will happen to the position of the equilibrium? According to the Chatelier'S principle, what will happen if some sulfur trioxide is removed from the vessel? Remember, this is an exothermic reaction. Removing sulfur trioxide from the vessel, the equilibrium is no longer there. So the position of the equilibrium, removing this, for an equilibrium to be established, what happened? More of the reactant will have to react to form more of the product. In that case, removing this will shift the equilibrium to what? Will shift the equilibrium to the right. So the B part of the B1 is equilibrium shift to the right for the production of more sulfur trioxide. Okay, what will happen to the position of the equilibrium when the pressure in the vessel is decreased or lowered? As I just explained, when the pressure is lowered, what happens to the position of the equilibrium? These are all gaseous molecules. There are three molecules here, two of sulfur dioxide plus one oxygen. That is 3 moles on the 3 moles of reactant and 2 moles of the product. 3 moles of reactant and 2 moles of the product. From the explanation I just gave you on the pressure, the pressure, the gas pressure is lowered. If the gas pressure here is lowered, what happened? To increase it, the equilibrium will have to do what? The equilibrium will have to move to the direction of more gaseous molecule, thereby saying that equilibrium will shift from right to left, from less gaseous molecule to more gaseous molecule. Once more, equilibrium will shift from right to left. That is from less number of molecule to more number of gaseous molecule. Thereby doing what? Thereby generating more pressure and establishing a new equilibrium. 3. What will happen to the position of the equilibrium when more of the catalyst, vanadium 5 oxide, is added? As we said, the catalyst has no influence on the position of the equilibrium. Adding or decreasing the catalyst will have nothing to do with the equilibrium. The catalyst is only there to increase the speed, or to increase the speed at which the equilibrium is established. So it has no effect. No effect on the position of the equilibrium. And number 4, the temperature of the vessel is increased. This is an exothermic reaction. Exothermic reaction favors the production of more sulfur trioxide. If we are increasing the temperature, we are doing well. We are favoring the endothermic direction. So if we increase this temperature, we are saying that more of the sulfur trioxide are going to be decomposed to what? To the sulfur dioxide and the oxygen. Therefore, shifting the equilibrium from left to what? From right to left. The equilibrium will move back to this direction, from right to left. Once more, if the temperature of the vessel is increased, if the temperature of this vessel is increased, the equilibrium is going to shift from right to left. Okay, state Le Chatelier's principle. I said Le Chatelier's principle states that if a system in equilibrium is subjected to a change, the system must react in such a way to oppose the change, thereby establishing a new equilibrium. If a system in equilibrium is subject to any change, the system must react to oppose the change, thus establishing a new equilibrium. Use Le Chatelier's principle to explain what will happen to the position of equilibrium in this reaction. We have here we have hydrogen plus carbon dioxide at equilibrium to give steam and carbon monoxide. What will happen to the position of equilibrium in the reaction when in this reaction when the concentration of hydrogen is increased. Of course, if the concentration of hydrogen here is increased, well, we have two, for gaseous molecule, we have two here and two here, two molecules on each side. That one has no influence. But now, concentration is what matters. Concentration. When the concentration of hydrogen is increased, the equilibrium is no longer there. When the concentration of hydrogen is increased, the equilibrium is no longer there. So to decrease or to have the equilibrium established, we need to do what? More of the reactant, the hydrogen and carbon dioxide must be decomposed for more steam and the carbon monoxide to be formed. In that case, a new equilibrium is established. Once more, increasing this distorts the equilibrium. To reduce this so that the equilibrium is established, more of this will be used up for the production of more of the product. Therefore, we say the equilibrium will shift from left to right. The equilibrium will shift from left to right. Okay, let's go again. Example number 2. Example number 2. On example number 2, we are saying methanol. Methanol can be produced industrially by reacting carbon monoxide with hydrogen. Carbon monoxide with hydrogen. This is the reaction here. Carbon monoxide and hydrogen to give a methanol. It is an isothermic reaction. This is an isothermic reaction. The process is carried out at 4 times 10 to the power 3 kilopascal. That's 40 atmosphere. And 1150 Kelvin. A. State Le Chatelier's principle. We have stated that. Once more, Le Chatelier's principle states that if a system is in equilibrium, if a system in equilibrium is subject to any change, the system must react to oppose the change, thus establishing a new equilibrium. From your understanding of Le Chatelier's principle, state the condition of temperature and pressure that could be used in order to produce an increased yield of methanol. Wow. In each case, explain why the yield will increase. From your understanding of this, state the condition of temperature and the pressure that could be used to produce an increased yield of methanol. Okay, temperature and pressure. This is a gaseous reaction. This is a gaseous reaction. What temperature must be used to increase the yield of methanol? What pressure must be used to increase the yield of methanol? Now, it's a gaseous reaction. It's an isothermic reaction. Now we have on the left, we have 1 mole plus 2 moles. We have 3 moles of reactants, and there's just 1 mole here. Since it is an isothermic reaction, we must do what? We must decrease the temperature. Isothermic reaction will favor the production of methanol. Therefore, decreasing the temperature will do what? Decreasing the temperature will favor more of methanol. Why do I say so? I say decreasing the temperature will increase the production of methanol. I say so. The explanation is that Being an exothermic reaction, decreasing the temperature favors the production of more methanol. Being an exothermic reaction, decreasing the temperature will favor the production of more methanol. Simple. Okay, pressure. What pressure? State the condition of the pressure. Is it increase or is it decrease? Okay. On pressure, we have 3 moles of reactant and only 1 mole of product. So now, to increase, and this is an exothermic reaction, to increase the production of more methanol, what do we do? To increase the production of more methanol, we need to do what? We need to do what? We need to increase the pressure. High pressure. High pressure will lead to the production of more methanol. Why do I say high pressure will lead to the production of more methanol? At high pressure, the gaseous molecule, more of the gaseous molecule of the reactant will do what? Will move to the direction of less gaseous molecule, thus reducing the pressure and favoring the production of more methanol. Once more, at high pressure, at high pressure, the gaseous molecule will move to the direction of less gaseous molecule, reducing the pressure and increasing or favoring the production of more methanol. Therefore, the equilibrium shift from left to right at high pressure. So, we have high pressure and we have low temperature. Now, so here we have high pressure. A low temperature will favor it, and here we have high pressure. Okay, then let's go to the second one. The third question. The third question here says, use this reaction. We have ethanoic acid and ethanol. Ethanoic acid and ethanol are reacting in an equilibrium. Okay. We have ethyl ethanoate that is formed. Ethyl ethanoate is formed. That's an ester and a molecule of water. Explain what happened to the position of the equilibrium when more of the ethyl ethanoate is added. What happens to the position of the equilibrium? Okay, when more of the ethyl ethanoate is added, when more of this is added, the equilibrium is no longer there. What happens? When more of this is added, the equilibrium will do what? The equilibrium will shift from right to left. When more of this is added, equilibrium will shift from right to left to favor the production of more acid and more of the acid and the ethanol, thus establish a new equilibrium. Once more, when more of ethyl ethanoate is added, the equilibrium has been distorted. For the equilibrium to be established, more of the ethyl ethanoate will decompose to what? To more of the acid and the ethanol. So equilibrium shift from right to left, thus establishing a new equilibrium. Explain what happens to the position of the equilibrium when ethanol is removed. When ethanol is removed in this system, when ethanol is removed from this system, what happens is this. When ethanol is removed from this system, the equilibrium is no longer there. When ethanol is when this ethanol is removed, equilibrium is no longer there. So for the equilibrium to be established, what happened? More of the ethanoate, ethyl ethanoate, will decompose to produce more of the acid and ethanol. Therefore, the equilibrium will now shift, but from from right again to left, to favor the production of the alcohol that has been removed. Equilibrium will shift from right to left to favor the production of ethanol that has been removed. Okay, use this reaction. Use this reaction. Ce4 plus ion 2 plus to give an equilibrium to give Ce3 plus ion 3 3 ion. Explain what happens to the position of the equilibrium when the concentration of ion 2 is increased. Increasing the concentration of ion 2, increasing the concentration of ion 2 plus. If the concentration of ion 2 plus is if the concentration of ion 2 is increased, if the concentration of ion 2 is increased, what happens? The equilibrium is no longer there again. The equilibrium is no longer there again. For us to have to restore the equilibrium, what happens? The equilibrium will shift from what? From left to right, and will favor the production of more of the Fe3 plus. For us to restore this equilibrium, when more of Fe2 is added, equilibrium will shift from left to right, favoring the production of more Ce3 plus and Fe3 plus. Explain what happens to the position of the equilibrium when water is added to the equilibrium mixture. When water is added to the equilibrium mixture, adding water to the equilibrium mixture will have no influence on the position of the equilibrium. The same number of moles, addition of water will not change the same number of moles of Ce4 plus, Fe2 plus, Ce3 plus, and Fe3 plus. Addition of water will only increase the volume, but will not change the number of moles or the concentration of these ions there. So will have no influence on the position of the equilibrium. Now, question number 4. Predict the effect of increasing the pressure on the following reaction. We have a reaction here which is dinitrogen N2O4 to give NO2. Here, predict the effect of increasing the pressure when pressure is increased. When pressure is increased, when the pressure is increased, what happens? We have 1 mole to what? We have 1 mole to 2 moles. Okay, predict the effect of increasing the pressure. If we increase the pressure here, from what I explained, only 1 mole of N2O4 and 2 moles of NO2. If we increase the pressure here, what happens? Increasing the pressure means that there is more frequent collision. There's more frequent collision between the particles and the walls of the container. So when there's more frequent collision between the walls of the container, between the particles and the walls of the container, what happens to the number of gaseous molecules? The number of gaseous molecules will move to the direction of less gaseous molecule to decrease the pressure. Once more, when the gas pressure is increased, there is more frequent collision between the gaseous particles. So to decrease the gas pressure, there is movement of gaseous particles to the direction of less number of gaseous molecules. So from what? We will not move from the 2 moles to 1 mole. In that case, the equilibrium will shift, but from right to left. The equilibrium will shift from right to left. More of N2O4 is produced when we increase the pressure. Now, effect of increasing the pressure. We have said effect of increasing the pressure will lead to what? Will lead to molecules moving to the direction of less number of gaseous molecules. So from right to left, as we said. Now, predict the effect of increase in pressure on carbon dioxide to this and that. Increasing the pressure here, pressure has nothing to do with sulfur. Pressure has nothing to do, with solids, sorry. Pressure has nothing to do with solid particles. So calcium carbonate and calcium oxide are of no use. So increasing the pressure will only favor the production of more of carbon dioxide. Okay, predict the effect of decreasing the pressure on the reaction below. On this other reaction here, N 2NO2 to 2NO. We have 2 molecules, 2 moles of NO2 with 2 moles of NO. 2 to 2. Now, no, not 2 to 2. 2 moles here. There's 3 moles. So it is 2 to 3 moles. Okay. 2 moles of reactant here to give 3 moles of products. Predict the effect of decreasing the pressure. If we decrease the pressure, what happens? If we decrease the pressure, to increase it, the particles will have to move to the direction of more gaseous molecule. If we decrease the pressure in this reaction, and according to the Chatelier'S principle, in order to increase it and establish the equilibrium, gaseous particles will have to move to the direction of more gaseous molecules. In that case, the equilibrium is going to move from left to right. Therefore, decreasing the pressure here is going to favor the production of more is going to favor the production of NO and more of the oxygen. So the equilibrium is going to move from left to right to favor the production of nitrogen oxide and the oxygen when the pressure is decreased. By doing like that, a new equilibrium is established. Another example of Haber's process is reaction with nitrogen. The Haber's process that's example number 5. The Haber process for the synthesis of ammonium may operate at a temperature of 450 degrees Celsius and a pressure of 1.50 times 10 to the 7 Pascal using an ion catalyst. That is nitrogen gas plus 3 moles of ammonia, 3 moles of hydrogen to give 2 moles of ammonia. The questions are: this is an isothermic reaction. A. Suggest why the temperature of more than 450 degrees Celsius is not used even though the rate of reaction will be faster. Okay. Remember, this is an exothermic reaction. Exothermic reaction will favor more yield or will favor the production of more ammonia. So, if we increase the temperature, above 450 degrees Celsius, what happens? It is instead going to decrease the formation of more ammonia. Increasing the temperature will shift the equilibrium from right to left, favoring the production of more nitrogen and more hydrogen. Again, increasing the temperature will favor the endothermic reaction, thereby favoring the decomposition of the ammonia into nitrogen and hydrogen. But at high temperature are going to increase the rate of reaction because at high temperature there is going to be more frequent collision between the particles, more frequent and successful collision between the particles. B. Suggests why the reaction is carried out at a high pressure. Why the reaction is carried out at a high pressure rather than at normal atmospheric pressure. Explain your answer. At high pressure, remember, at high pressure, there is more frequent successful collision between the particles and the walls of the container. So in order to lower the pressure and establish an equilibrium, gaseous particles will have to move from the direction of more particles to the direction of less particles. In that case, there will be movement from left to right to favor the production of ammonia. So our reason why it is carried out at high pressure is because at high pressure, more of ammonia will be formed. At high pressure, more of the nitrogen and the hydrogen will combine in the formation of ammonia. High pressure favors the production of more ammonia. So equilibrium is from left to right. Explain why the removal of ammonia as soon as it is formed is an important part of this industrial process. You should remember that ammonia has a higher boiling point than nitrogen and hydrogen. Ammonia is condensed to liquid when it is formed. So, ammonia is removed immediately as it is formed, because if allowed, it will decompose back into what? Into nitrogen and hydrogen. Once more, ammonia is removed as soon as it is formed, because if allowed there, it is going to, since it is a reversible reaction, it is going to be decomposed back to the reactant, nitrogen and hydrogen. So it must be removed as soon as it is formed. The D part of it, when ammonia has when the ammonia has been removed, why doesn't it decompose back to nitrogen and hydrogen? Ammonia has been removed from the system, but prior to its removal, it does what? It is condensed to liquid. Ammonia is condensed to liquid, and beside that, it has a higher boiling point than nitrogen and hydrogen. It makes it difficult to be decomposed back to nitrogen and hydrogen. The reason is ammonia has a higher boiling point than nitrogen and hydrogen, and it's difficult for this liquid to be decomposed back to nitrogen and hydrogen. Finish. We can still use this to explain, according to the kinetic. You could be asked to explain this high temperature, high pressure catalyst, and high temperature and catalyst in terms of the kinetic theory of gases. It's a gaseous reaction. How can we use this to explain in terms of the kinetic theory? Remember that the collision theory has to do with the collision of particles, how the frequency of collision of particles. For particles to, for a reaction to occur, particles must collide, and they must collide in the right orientation. They must have sufficient energy, activation energy. So let's use this condition and apply them here. High temperature. At high temperature, in this reaction between ammonia and hydrogen, what happens? At high temperature, what is going to happen is that when there's an increase in temperature, particles acquire, there is going to be an increase in the average kinetic energy of the reacting gaseous particles. When there is an increase in the average kinetic energy of the gaseous reacting particles, there's going to be an increase in successful collision. There's going to be an increase in the frequency of collision, leading to more successful collision. When there's high pressure too, when there's high pressure, as I earlier told you, when there's high pressure, it means there is more frequent and the successful collision between the particles and the what? And the walls of the container. High pressure gives more frequent collision between gaseous molecule and the walls of the container. What happened with catalyst in terms of the kinetic theory? The catalyst will only lower the activation energy. It only lowers the activation energy. And in terms of Kc, all of them will not have anything to do with high temperature and the catalyst. At high temperature, well, in terms of Kc, as we earlier said, high temperature in terms of ammonia will give less yield. So now you will be expecting similar questions in your exams. So learners, go solve more examples on Equilibria and the application of Le Chatelier's principle. Thank you for listening. Like, share, subscribe, and continue listening to more of our videos and tutorial lessons. Thank you.